In this video, we're going to start to look at how to create modular systems with Scala 3. And this information here comes from the second edition of the Scala cookbook, and this was a recipe that I called Building Modular Systems with Scala 3. And this recipe comes from Martin Odersky's statement that Scala developers should use functions for the logic and then use objects for modularity. And because people may not know what that means, that's where I get into this recipe about how to build modules in Scala. So to understand this solution, you have to understand this concept of a module. And in Programming in Scala, which Martin Odersky co-wrote, he describes a module as a smaller program piece, and it has a well-defined interface and a hidden implementation. And that sounds like a few other things in programming. So more importantly, he adds these other notes here. Any technique that aims to facilitate this kind of modularity is going to need to provide a few essentials. So he goes on to list those essentials. And he said, first, there should be a module construct that provides a good separation of interface and implementation. So in Scala 3, we have the concept of a trait, which can be used as an interface, and then an implementation can be taken care of in a class or an object. And second, there should be a way to replace one module with another that has the same interface, and that's without changing or recompiling the modules that depend on the replaced one. And kind of a short story here is, if you think about the concept of a database, for a database, you're going to have an interface, which will be created as a Scala trait, and then you'll have concrete instances of that database created as different objects. You'll have one object created for your development environment, another one for the testing environment, and then a third one for your production environment. So that's what he means in this statement right here. And then lastly, he notes that there should be a way to wire the modules together, and this wiring task can be thought of as configuring the system. And I kind of gave away these points already, but Scala provides these solutions for these problems right here. So the first solution is inheritance and mixins with traits, classes, and objects. This gives us a good separation between interface, which is typically the traits right there, and the implementation, which is going to be these other guys over here, classes and objects. And then, as is described in this paragraph here, inheritance gives us a mechanism for one module to be replaced by another. And in regards to this third point, there's this statement here that creating objects, they use the word reify. Reify actually means to make real, is what that means right there. So when you reify something, you are creating objects, Scala objects, from traits. And you'll see what that means in the examples that follow. And I give a real quick summary of what this means right here in this pseudocode right here. So as I mentioned earlier, you're going to start with a database trait. Then you might have a mock database or something else for your development environment. Then you'll have a test database object, and I should note that this is a trait and these other ones down here are objects. So you'll have a development database here, a test database, and then a production database. And these are three different objects, and they'll have the exact same API that's based on this trait right here. So even without writing any code or much code, this gives you an idea of what a modular approach looks like. And I'll note here that programming with modules in Scala goes like this. So you're thinking about your problem, and you might create one or more base traits to model the interface for the problem. Then you're going to implement your interfaces with functions in more traits that extend the base traits. And by that, I mean that we're going to be implementing those here, here, and here in this example. And then when you're using multiple traits and you want to combine or compose those, that's something I'm going to show in just a few moments. And then when you want to reify or make things real, that's when you create an object from your traits. So this is, again, that reification step. So an example goes like this, and let me go ahead and start moving things around a little bit so we can start working here. So what I have going here in this environment is I'm working on a file named modules.scala, and I have it running with Scala CLI over here and the usual watch option. So that continuously compiles and runs this program right over here in my terminal. So the example I show over here is, let's say that you want to model the behaviors for a dog like an Irish setter. And one way you can do this, and this is what we did in the old days, we just started writing a class for an Irish setter, and then we would start implementing its behaviors here. And generally, we don't do that much anymore. I guess I should back up and say that you can start this way. There's two ways to develop. You can start by developing smaller traits and then combine those to create a full class like this, or you can create a full class and then realize, oh, okay, I've got some different things going on here, so I want to break that up. So what I'm going to do is start with the technique of breaking things up. So I'm going to have like dog tail services here and then dog mouth services over here. And that's what I mean. If you would put all of these into a class right away for wagtail, lower tail, raised tail, and then bark and lick, if you'd put all of those into a class, sooner or later you'd realize, oh, I can put these under a dog tail, and then these all go under the dog mouth. So then you would break them out into traits later. I'm just going to start with the traits first. And that's typically the way I program these days. So again, as I show here, initial thought is that a dog is an animal. So you may start off and say, well, I know that a dog is an animal. So that's step one right there. And then you might think, well, a dog is an animal that has a tail, and that tail has a color. So you might create that code. So you would create that as an abstract class in this case, animal with tail, and then tail color is the Java color type right there. And that is that one, and it extends animal. And the reason I'm making this abstract to start with is because animal at this point doesn't have any methods. So this class here won't have any methods at this point anyway. It may have methods later, but it doesn't right now. So I'm just making that abstract to begin with. We can always change it later. And then as a note right here, since a dog has a tail, you would start to think about, well, what kind of behaviors can a tail have? And this again is a part where you could say, well, if this was a class, I might start putting these in here. And then I would say, well, with a tail, you could say, well, I want to wag the tail, and that's going to have something going on over there. Then I can lower the tail, and then I can raise the tail. And again, all three of those are TBD or to do later. That's why we use those three question marks there. But in my case, I'm going to go back to the way I had things before because I like to think in terms of traits, and I like to think, well, a tail is a discrete unit on a dog, if you want to think about it that way. So in this case, we could say, well, we have these dog tail services, and they are going to be like that. So again, these methods are TBD. I haven't decided what to do with those. I just know that I want things like that for a tail. And the other thing we can do in Scala that I note here is you can add what's called a self-type to this dogtail services. And you can say that anyone that tries to implement this trait right here, dogtail services, must be of the type animal with tail. And the way you do that in Scala is like this. And I've always thought that was a bit of an unusual syntax, so that's why I put a comment in there and I say implementers of this trait must be a subtype of animal with tail. So that's what that line means right there. So again, you include that because you want to say, let's say if you had a human and you were making a mistake in your code and you say, well, I want this to extend dogtail services for some reason. You want this to fail because a human is not going to extend animal with tail. So that's a really great thing about this line right here. This is a way of telling the compiler the only types that can use dogtail services are the ones that implement animal with tail. So the only way you could get this to compile would be if the human extended not just dogtail services, but also animal with tail. And hopefully when you type that, you realize, oh, something's going wrong here. And that particular code won't compile because that's an abstract class, but that is a totally different point. The point I want to make is you don't want to allow that, and that's what this line of code does for you. And I described that over here, so if you want to pause the video and read that information, it's all right in these paragraphs right here. And to keep things simple, I go ahead and implement these methods right there, so that's what I'll go ahead and do here. And now I can just replace all of that code with this code right there and save that. It looks like everything's good so far. And now this takes care of the dog tail. And the next thing I think about with the dog is, you know what? It has a mouth. And so now what I want to do is create these dog mouth services. And in this case, I go ahead and implement those right away. So here with the dog mouth services, you can see that I do the same thing. I also say in this first line right here that anyone that tries to implement dog mouth services must also be a subtype of animal with tail. And then I add in the bark and lick methods right here. And I should note that this is not a great example right here because that really should be something more like animal with mouth. And I don't have that type in the system right here, so that's why you get that error message. But for the time being, I'm just going to leave that with animal with tail, and then maybe we'll come back and look at changing that later. But the reason this should be animal with mouth is because all of these methods inside of here pertain to having a mouth. So that's why I mentioned that. But I'm going to go back to tail for just a few moments anyway and leave that like that. And then as I note over here, I could keep going on like this, and we could say, well, when you think about a dog, you might have something like leg services because animals have legs. So you might have leg services, and then it might be something like walk equal ... Then might run might equal that as well. And then you might have, well, a trait with fur services because most dogs anyway have fur. And then you could say, well, def shed equal that. So the dogs could shed their fur. But for our purposes, I'm going to go ahead and stop here. But I do want to show that you can just keep creating more and more services as you need them. And then what's going to go on is we're going to create our module like I show right here. So now coming back to the code over here, the way you create a module in this particular case is I say, well, I want to have an iris setter, and it's going to extend animal with tail. And animal with tail is an abstract class, so that needs to be the first thing I extend right here in Scala. So I'll say, well, I had an iris setter growing up and its tail was red. So that's what that is. So it extends animal with tail. And it's also going to extend dog tail services. And it's also going to extend dog mouth services. And I kind of like the way I formatted that in the book better. So I'll go ahead and do that. So this is actually creating a module for an iris setter. And this is that reification process that I was talking about earlier. So if you think about it, everything up here is abstract. This, of course, is abstract. A trait right here you could think of as an interface. In this case, I've implemented these methods, so it's not quite that abstract, but you could think of this as being abstract as well. And now when you create this object, now you're starting to make things real. So now I've made an iris setter a real thing. And again, we use the word reify or reification at this point. And I believe the correct term is that we say that we're reifying an iris setter from these other abstract classes and traits right here. And I note here about the color, I've already imported the color up there. So now since I've gone ahead and made that real, what goes on down here is you can say, well, I can now have an iris setter and I can say, well, I want to wag the tail. And then I can have an iris setter and bark like I did. And save that. And now you can see the output over here. So it's wagging tail and barking. So all of this shows what we mean by this process of modules. And specifically now you can think of the iris setter as being a module in this example because we built it and made it real from these other traits. So if we go back to this original description that we had here, there should be a module construct that provides a good separation of interface and implementation. So that module construct in Scala is the object keyword right there. We create an object from these other traits over here. And the traits provide the interfaces that we want. And an interesting thing about Scala is the traits can also provide an implementation, as I've shown here. If you wanted a different implementation in the iris setter, of course, you could come down here and I would probably reformat this a little bit. So just bear with me there for a moment or two. And now if I wanted to provide the behavior here, I could say, well, override def wag tail. And then I could just say something different. So now I can say, well, I'm wagging my red tail and then save that. And you can see that output over here. So the reason I'm mentioning this is because these methods may be abstract. So all you'll have for the definition is that. So that's what I mean by interface, is that this is just an interface right here. And if you want to use Wagtail, you're going to need to give it an implementation. As I mentioned right here, you'll need to give that an implementation when you create this module right here. So that is the module construct and the interface and the implementation. In a few moments, I'm going to show about how to replace one module with another that has a similar interface. But what I mean by that, actually, I could show that here, and that would be something like, well, I could create now a Siberian Husky, and it's an interesting one because its colors will vary, but let's just say it is white, or it could be black, or again, the problem there is that it varies. So here I could say I am wagging my multi-colored tail and save that. So I'm not actually calling that down here. But what I wanted to show is there can be a way to replace one module with another that has the same interface. So that's what I'm doing here. And you could keep creating all the objects and all the modules that you want for different dog types and different dog breeds here, and then use them down here. So if you wanted to replace one with the other, then I could say, well, I want to put the Siberian Husky there. And then you see that output over there. And then the wiring mechanism that we talk about here is simply this way of extending all of these services right here. Actually, you could think of it in a couple of different ways. It's this process of extending all the services that you want to include here. And that wiring control also actually kind of comes in here as well. So again, this was our way of saying, if you want to use dog mouth services in your module sometime later, you must extend animal with tail. You must be a subtype of animal with tail. And a way I can demonstrate that this works is to say, well, instead of an animal with tail, what if we had an animal with mouth, like I talked about before? So now I would change that here, put that in there and save that. And right away, you see the code fail over here and over here. And that's because Irish Setter and Siberian Husky don't extend this new trait, animal with mouth. So if you wanted to see those errors go away, we could add animal with mouth over here, and then you'll see that red line go away there. So now this one is failing because it doesn't extend this, but this one is working because it does. And if I was going to make this a little more real world, I would do that, then I would do that, put that there, and in this case, make those abstract. And again, in this case, I'm starting to make this code more real world-like because this is a simple interface for an animal with mouth. And now I'm saying that for something to have mouth services, it must mix in this animal with mouth trait. So these are abstract, and then I make sure that I implement them right here. And now Irish Setter won't compile until I add in animal with mouth there. And now you see the error messages go away and we start to get regular output again. So I apologize for that. I hope that wasn't too confusing, but it was bothering me that I had these mouth services and these are behaviors for a mouth. And then I was requiring animal with tail. That just didn't make any sense. So I wanted to fix that before I finish this video. So now with this line right here, I'm saying that if you want to use any sort of dog mouth services, I'm requiring that you must mix in animal with mouth. And animal with mouth provides this interface up here. And then in the services here, I implement those interfaces. That makes much more sense. That's why I want to go ahead and fix this. And I also wanted to show that if you do not include that in there, you will get that error message right there. And that's because of that line right there. Now, a couple other notes I want to make. The first one is why I keep using the word service over here. And the name service comes from the fact that these functions provide these series of public services that you are going to make available to other developers. And the way I like to think about this is if you think of this as being a web service type of call, then you can think, oh, okay, I'm working with this REST API and it's called Dogtail Services. And the services it provides are wag the tail, lower the tail, and raise the tail. So that's where the name services comes from. And I think it's fairly popular now. So hopefully we won't have to explain that much more. But that's the way I'd like to think about that is when I think about REST services or web services. The other thing I want to note in the discussion here, I have the reasons for adopting a modular approach. And again, we go back to the book Programming in Scala. The first one is that as a program grows in size, it becomes increasingly important to organize it in a modular way. So you can see over here, it's really nice when you're programming to just be working with small modules. And when I'm working with this code that I have here in blue, the only thing I have to worry about is the dog tail. I don't have to think about the mouth. I don't have to think about the fur or anything else. All I have to worry about is this tail. And then you can mix that in over here. And if I feel really comfortable that my code is really nice and bulletproof up here, it's really nice then that you can mix that in as just a small little service down here into your much larger module. A second note is that being able to compile different modules that make up the system separately helps teams work independently. So a nice thing also is that I can work on dogtail services while somebody else is working on the mouth and somebody else is working on the body and the legs and the fur. That's another great reason to have modules. And then the third thing is what I talked about before, is that when you have different modules, you can use them in different contexts. And that gets back to this point here. So if you start off with a base trait for a database, then you can have different configurations for different systems. So again, you might use a mock database in your development environment. You might use a test database in the test environment, and then a production database, of course, in production. And that's what Martin Odersky means when he's talking about these different contexts over here. Then if you're interested in more details, I've linked to an article over on the Artima website. And Artima and Bill Venners are the ones who created the Scala test environment. So if you want to read that, I think that's a pretty good article. It's pretty detailed, but just come to this page and then click on that link so you can find that. In summary, in this video, I showed how to build modular systems with Scala. So we started off by showing Martin Odersky's quotes about what a programming language needs in order to support a modular system. And then I talked about how Scala has these solutions that help us build a modular system. Then I showed the thought process for creating modules in Scala. And then we went through this example all over here. And then one of the last things I showed was the reasons or motivations for adopting a modular programming approach. And the first reason here was keeping things small so you only have to focus on one thing and you can make that one thing as bulletproof as possible. And then another benefit of that is that I can work on this system here while you're working on this one here, and other people are working on other traits. And then when we're ready to reify those traits into a module or an object, we just do that as shown right here. And then finally, I started to show the ability to unplug one implementation and plug another one in. So I started to do that over here with the Siberian Husky, replacing the Iris setter very easily right there. And a real world use case of that is this database setup that I've talked about several times now. So if you're interested in modular development in Scala, I hope this has been helpful.